Okay, this is Professor Laird, and this is the video lecture on the scientific method. This is a class that I give to all of my classes in social and political science because it's a very important topic to understand and appreciate what the scientific method is and how important it is into the study of social science and political science. Before we get into the actual definition of the scientific method, let's talk a little bit about why we as human beings have a tendency to disregard science, perhaps discount it somewhat. And this is part of how we are as humans. We've spent a long time evolving into the humans that we are today. And for much of our development of our brain, we were using our System 1 thinking, which is based on our intuition. Our intuition is extremely important. That allows us to use our senses to figure out what's going on and make quick decisions based on what we see or what we sense or what we've experienced. So obviously, intuition is very important. You could perhaps argue that as we were developing as our hunter-gatherers, we would use our intuition quite a bit, our System 1 thinking, to react the flight or fight syndrome that our brains really became brains using predominantly this System 1 thinking. However, as our brains developed, most importantly, as we developed modern civilizations with agriculture and larger and larger communities and more institutions that made our lives more safe, more orderly, more organized, and then particularly as we get into modern science, mathematics, philosophy, we start to develop our System 2 thinking. You could even perhaps argue that with the development of the printing press, it really gave humans the opportunity to read more and use their brains more, to reason, to calculate, to use probability, to use logic, introspection. Very important in the development of our brains, taking it to the next level. But as you can see, our System 2 thinking is relatively new, comparatively speaking, to our long couple of million year development as modern humans all the time. And you could certainly argue that most people feel like that their intuition, the System 1 thinking, serves them well. But when it comes to taking it to the next level of problem solving, obviously our System 2 thinking has done extremely well for us. But you could also say that System 2 thinking is not natural to our brains. Our brains actually became human just using the System 1 thinking and intuition. We also have a tendency to use what these are called our heuristic devices. Basically, they're mental shortcuts that we're very good at doing. It's stereotyping things, making analogies between things. I am from Texas, and so I kind of do this as a class exercise and get the class to tell me what stereotypes they have of Texans, and there are quite a few of them, and I fit very few of the stereotypes that typically come up in class. So that's how much shows you that they aren't necessarily accurate. They're just a simple way of our brains to categorize things to make it a little bit easier for us to understand. We also have a need to reduce complexity. We're always looking for either or answers, right, wrong, good or bad. This is what we call patternicity, imposing structure on things, looking for patterns. And our brains are also very much geared towards distinguishing between good and evil, and that's how we can get literally persuaded to doing things that might be harmful to us because of this good versus evil divide. Might get us into wars that may not necessarily be worth getting into or turn out to be fairly unproductive. So what this means is that our System 1 thinking, which is based on our beliefs, our perceptions based on those beliefs, our opinions, could even argue that our passions. This is what James Madison wrote in Federalist Paper number 10, that the impulse of passion is going to put people into factions and it's going to create a problem for democracy. So he came up with the representative republic to try to diffuse these all these various beliefs and opinions through a medium of our chosen representatives. So that's kind of what drives us. So System 1 thinking is more normal, natural to us. System 2 thinking is something that we really have to work at and think about. Now, there's an article that if you haven't been assigned this article already, I will assign it to you, kind of in conjunction with this particular lecture. And the name of the article is called The Science of Why We Don't Believe Science. And one of the examples that this article talks about was the cult called the Seekers. This is back in the 50s, and there's been other mini cults before and since that have shown examples of how that we can get caught up into this rationalization process. But rationalization is something that we kind of do on a fairly regular basis when we're using this System 1 thinking. And what this ultimately leads to, particularly with scientific analysis, is what we want to avoid this, most importantly, for your paper assignments, is that you want to avoid this confirmation bias, which means that you are specifically looking for those facts, because there's lots of facts out there. So you're cherry picking those facts that support your belief, your point of view, and you're conveniently ignoring the others that could be counter to your view. And this is what the peer review process attempts to do, is try to weed out any bias that an author might have in the preparation of his scientific analysis. The scientist has already been trained to try to minimize that, but again, it's hard to completely avoid because we're human, and there may be certain biases that drive us to study something in the first place. So we've got to be careful about that, and the peer review process is what tries to weed that out. Now, education, interestingly enough, may not change people's views because the socialization process is very strong. We're socialized to believe various things, whether it's socializing people into certain customs, certain traditions, particularly into religious beliefs, and even ideological beliefs. People are socialized by their parents into following a political party. And this conformity is also very strong to our nature. Conformity goes all the way back. Conforming to your group is what helped your group survive. If everybody conformed to the common goals of the group, which was survival back in those hundreds of thousands of years ago when we were trying to survive in the hunter-gatherer small groups, well, that's part of what's natural to us, is that. And so once you've been socialized and then you get out into the world, that stays with you. That's not something that you're typically going to learn out of or perhaps change your belief. Obviously it does happen, but it's a pretty strong hold on us. So it takes effort, obviously, along with this education to say, okay, well, maybe I am being biased here, or maybe that if I wanted to understand this better, I would let go of some of my biases or beliefs. Groupthink is a common problem that gets into relatively small groups of leaders and decision makers. And there's been some famous examples over the years. Scientists will argue, particularly political scientists, will argue that the Vietnam War was a common, or well, as a very strong example of groupthink. Particularly, everyone in the group was dedicated to fighting the evil of communism. Some people argue that the Iraq War, that was led by a relatively small group of insiders that were really kind of focused on getting rid of Saddam Hussein, at the risk of coming up with some reasons that turned out later to be not valid reasons. So this collective faith to a group, or the loyalty to this group or to the leader. Another thing that we typically want to do with our System 1 thinking is when something happens to us that's bad or unfortunate, it's difficult for us to blame ourselves or to find what potentially could be the reasons for it, and then look for someone else to blame. Particularly a politically accountable villain would be a something that we would generally do. And one example is this article slipped through that correlated the child vaccinations with autism, and it created quite a firestorm of controversy, and it was disproven relatively quick and has not been duplicated since. In the aftermath, a lot of people latched on to this finding that they would hear, and then they would put things together. Over the past 20 years, there's been quite a bit of people who have literally kind of advocated against child vaccinations, and it's been a pretty serious problem in that measles outbreaks, whooping cough outbreaks, the types of diseases and illnesses that were very much preventable with these child vaccinations. We've seen very noticeable spikes and higher outbreaks. But this is, again, an example of how our System 1 brain wants to work. Max Planck, a Nobel Prize-winning physicist, quantum theory, quote here, that a new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die. And there's Max Planking right there. Sorry about that. I couldn't resist. I don't even think planking is even cool anymore. Some other things that we're very susceptible to is social influence. I've already talked about conformity being somewhat natural to our brains in order to create order and survival, that sort of things. But we do know that this is why economists study about incentives. We know that individuals can be nudged into doing things based on what other people are doing. And this is why we are good at emulating what other people are doing. If it works, let's try that. This is why advertising is so effective. Other people are buying it. This is why we get into these fads and waves, and even in some cases fits of panic and hysteria because of what other people are doing. We jump in on that and get convinced to do it. Very prominent philosopher says when people are free to do as they please, they usually imitate each other. And so that's another example of how our brains work. Not good, bad, right, or wrong. This is just how we operate. And if something looks like it's a good idea, why would you not copy that anyway? That's one of the things that we see in international relations. When one country is doing something that's successful, other countries could emulate that, particularly if it's some sort of economic process or whatever. Now, the problem we see here with our policymakers, our politicians, our decision makers in government, what we see is that the more and more they start to divide up into their ideological divides, party loyalty, what we're seeing is that policymakers are relying more and more on intuition as to the causes of problems rather than studying. So that's one of the problems with government that we might be seeing, is that if we already know what the answers are, if we already know what's right and wrong based on what I've been socialized to believe or what my party loyalty is, well, elect me so that I can make sure that we're doing what the right way is, rather than studying problems and analyzing them and trying to come up with a solution that may have the best benefit. Now, I've been guilty of this and say, well, now this is not rocket science, this point I'm trying to get across here. However, this is what's somewhat ironic about it. We actually know more about rocket science than how the human brain works. And the human brain is a product of nature. And so if somebody tries to discount social or political science, the first thing I'll say is, well, no, because social and political decisions are made by our brains, which is a product of about 6 million years of human evolution in nature. So can't get more scientific than that. Now, common sense is a product of our intuition and our System 1 thinking, which is valuable to us. Common sense is knowledge that can be learned by simply participating in society, by experiencing life. If you travel a lot, you'll have more common sense on how to get through airports or how to negotiate your way in strange territory. That's just because of your experience of life, of participating in society. Very, very valuable part of learning, right? Learning by experience and enhancing your senses and your experiences. Now, however, we got to be careful, because if we rely on common sense to potentially solve problems that are relatively difficult, then common sense could kind of fool us into making errors of reasoning because we already think that we've got it figured out. And then another thing that common sense will do to us is that we'll fall back on these common sayings of behavior, these common assumptions of how people behave. I've been around, I know people. Well, yes, you might know people and have experienced a lot of people, but when it comes to solving problems based on costs, benefits, incentives, etc. Here's an example where, let's just say we're out in an open field, and what we have is a gun pointed straight out, loaded gun, and we have a bullet. We're also holding a bullet in our other hand. And so the purpose of this experiment is that I'm going to shoot this gun straight out into the field. We've made all the safety precautions that we need to make. It's open, clear field as far as we can see, nobody around. So what I want to do is drop that bullet as soon as we shoot the gun. And I think what we will probably already see what's coming here is that the instant that I shoot that gun and then I drop that bullet, what our common sense will tell us is that the bullet that we drop is going to hit the ground a lot sooner than this bullet that's going to fly way out here into this field. It's going to hit the ground here quicker than this bullet is going to get out there. And that's common sense. That's because I've asked this question in all of my classes for many years, and it's almost unanimous, at least as far as the students that respond, that yeah, that makes sense, that this bullet is going to hit the ground that I drop here quicker than this bullet that's going way out there into the field. Well, what physics tells us is that those bullets are going to hit the ground at exactly the same time. Now, of course, this is taking into account no wind resistance, because wind resistance is going to provide a little bit of a deceleration effect on this bullet here. But discounting for wind resistance, and any elevation differences, we know, and we can prove it on a small scale with ball bearings fairly easily, that these are going to hit at the same time. As this bullet is dropping, this bullet is also dropping because of gravity, and they hit the ground at the same time, and that's hard for a lot of people to wrap their head around, but that's where our common sense could potentially mislead us into making wrong assumptions when calculations and analysis proves otherwise. So this brings us to the scientific method, which came into being particularly in the Renaissance period into the Enlightenment, where theories by Copernicus, as far as the Earth revolving around the sun instead of what we had believed for many, many centuries, Galileo and Kepler that built onto that. And then as we get into the 1600s, we see that mathematician philosophers in particular, such as Descartes, Francis Bacon, started to come up with this scientific method of trying to figure out how things work rather than just make these assumptions based on religious beliefs and dogma. And so then, particularly as we get into the 1700s, well, particularly the late 1600s with Isaac Newton, that really kind of took it to the next level with physics and calculus. And then as we get into the 1700s, well, we started to see, first of all, John Locke with more political philosophy. We already talked about Hobbes in his theories on political states. And then we get into the 1700s with even more philosophy on science and politics, such as Hume. Some landmark works. We talk about Adam Smith and Montesquieu, who came up with the three branches of government, checks and balances, that led right on up into our Constitution, which was a product of this Enlightenment thinking that utilized a scientific method. So our general definition here is this: it's a systematic, organized series of steps that ensures maximum objectivity and consistency in researching a problem. And what we've seen is that, yes, despite how laborious this could be, it is responsible for essentially all the gains that we've made in understanding the natural world. Incredibly important. And if we start to discount this scientific method simply because we already think we know what's right and wrong, or that it's not going to really be useful to us because this is what I believe, and if science is going to counter my beliefs, well, I don't really even want to go there. And so that's why it's extremely important, and why I teach it in every single class that I teach, is that the maintaining the appreciation and the credibility of a scientific method is extremely important, and that will be kind of a guide for you when you're writing your papers. You want to be analytical, objective, consistent, using analysis to tell me what you've learned, not what you think is good, bad, right, or wrong. That is not going to be a good paper if you do that. What you want to do is read a lot and then tell me what you've learned in an organized, analytical, interesting method. And then the next video I post in some classes is going to be a lecture on writing your paper. Here's what people have a problem with. Science by nature is incremental and self-correcting. Could actually get it wrong, and then somebody has to come back and look at the data, and perhaps it starts to correct itself with this process. And so we have to be careful. We need to be able to distinguish between scientific sources and popular sources. That doesn't mean that popular sources are bad. And I'll talk about this in writing your paper is that your scientific sources are the ones providing analysis, and your popular sources are the ones that's providing the news, right? Two totally different things. And particularly in our internet age of the digital world, that we're constantly bombarded with inflammation, effluvium, and just every single day, years and years and years of data are being uploaded into the internet, and a lot of it is just pure useless junk, but a lot of it is very useful, credible information right there at our fingertips. And then, since there is so much information out there, that perhaps even facilitates our inherent tendency for confirmation bias to go out there and find that information that confirms what we already believe. Well, that's not the point. We're trying to go out there and figure out what's really happening, how things work, why human beings do the things they do, what's causing the problem, why, how come. A hypothesis is a relationship between two variables that you are trying to test. So if I have some variable x, which is my independent variable, and then I have some dependent variable y, so I would come up with some sort of test or data that I could collect and then figure out some way to test this relationship or to measure this relationship so that I can see that, yes, something about X is significantly related to Y. It may not necessarily be causing Y, but it could certainly be contributing to Y. A theory is the overarching idea or assumption that attempts to explain or predict. And so you can have a theory from observing what's happening, looking at the phenomenon out in the world, and then trying to come up with a theory of what's going on from your observation, or you can be interpreting lots of facts and data and information that you're gathering or collecting, and from the interpretation of those facts, you could come up with a theory as to how things work. Now, this is a very important question. What makes a theory a theory? What makes it a valid, credible theory? What makes it a theory in the first place is that it's falsifiable. It can be disproven. If you can't disprove it, it's nothing more than just some belief or just some pseudo-science out there that we want to believe, whether it's astrology or some sort of religious faith. Again, this is not meant to downplay any value of religious faith, but that's not a theory. Can't prove it or disprove it, either one. But so that's what's very important about a theory, is that it can literally be disproven. That's the very big dividing line there. If you are trying to utilize a scientific method to design some sort of research project, well, there's lots of different ways you can do it. You can collect data. You can try to find credible sources. You can make representative random samples, try to make it as unbiased as you can. The bottom line is that you're trying to make it valid so that it accurately reflects what's going on out there, and that you want it to be consistent each time that you would test this so that results are reliable. There's some more examples of research here: surveys, questionnaires, polls, interviews. The whole point is to try to be random in your selection process to make it as representative as you can of the larger population, as well as unbiased, and trying to create reliable, valid results. Got some other things here as far as case studies, participant observation, which is what anthropologists do quite a bit. They go and literally cohabitate or kind of live amongst the people that they're observing. And then there's lots of experiments that you could conduct. The control group versus the experimental group is a very common experiment, particularly with drug studies where somebody's taking a placebo and the other person's taking the actual drug and they don't know which is which, and they check the results. And then we've got other examples here that are non-experimental. So what I'll leave it here for now. I'll post another video later on tips for writing your paper.